Good morning and welcome everybody to this Baltic Breakfast on pollution from shipping on this beautiful Wednesday morning. And welcome to you who follow us online. My name is Ellen Bruno. I work at the Stockholm University Baltic Sea Center. We conduct research on the Baltic environment and we try to facilitate exchange between research and policy making. And as, for example, today we try to, when there's new research findings that actually asks for policy action, to raise those issues as well. And you've all seen the pictures, I guess, of oil spills and things floating on the surface of the Baltic. And just last week we had a big palm oil spill outside Gotland, actually in the winter ground of Longtail Dock. And you might have thought it was a PR trick for this seminar, right? But it wasn't me, and it actually wasn't an accident either. It might have been more or less legal if you follow the protocols, but it wasn't prosecuted as far as I know. So today we will learn a little bit more about those rules and procedures and what's actually needed to change the situation and to reduce pollution from shipping to the sea. And helping us today is Ida-Maja Hassellöv and Lunde Hermansson. You're both from the Chalmers University of Technology, right? And Maritime Environmental Science. And you will talk for around 30 minutes, and then we will have 50 minutes for questions, so please prepare. Both you at your computers and here in the room. And although we speak English today, you can always ask questions in Swedish or Norwegian, and we will try to translate as good as we can. So without further ado, Ida-Maja, you're starting.
Yes.
So please welcome.
Thank you very much, Ellen. And first of all, good morning and thanks to Baltic Sea Center for inviting us here today. The outline of today is as follows. So I will start to provide a little broader context about environmental pressures and impacts from shipping in general. And then I will hand over to Anna, who will talk more in depth on tank cleaning. First about what it is, what type of problems it causes, and finally also something about solutions that we are proposing in this policy brief that we have just produced within the shipping group of the Swedish Institute for the Marine Environment. And we have been working on this topic with tank cleaning since 2019. And Eva-Lotta Sundblad, who is sitting there, is the chair of the shipping group at the Swedish Institute for the Marine Environment. And she has played a key role in getting together all the relevant public authorities. So a lot of collaboration between different agencies and also a long range of public actors and stakeholders. And more information about this work is found on the Institute's website. So. But if we then start to look into the operational emissions and discharge from shipping, this today is not accidents that are our focus, but from normal operation. So every ship during normal operation will exert a range of pressures on the marine environment. And in this figure, it's illustrated with all the arrows from different onboard systems. And these onboard systems are usually to some extent regulated through different shipping regulations. And the masterpiece here is the International Convention for Prevention of Pollution from Ships, in short MARPOL, that has 6 annexes. And for tank cleaning, there are 2 of these annexes that are relevant. So it's Annex 1 that is focused on petroleum oil products, And that will not be the focus of today's talk, since that is prohibited in the Baltic Sea. But this other Annex 2, is handling other types of chemical products, including vegetable oil and, as Ellen mentioned, palm oil, for example. So that will be the focus of our discussion here today. And all these different onboard systems, oh, now it's very loud, is then giving rise to different type of pressures. So as we can see here, for example, nutrients can come from ballast water, it can come from black water sewage, from grey water, also from tank cleaning, etc., etc. So if we switch the perspective a little bit and look instead from the marine environmental management perspective, then if we are discussing the environmental impact of shipping, we need to consider the combined pressures from all these different onboard systems, from all ships that are operating in an area. And this is a picture showing the activity during one moment. So you need to consider the cumulative impact from all these ships at the same time in the geographic area of interest. And despite this, most holistic assessment that try to assess the impact of shipping, they fail to consider all these different types of impacts. And if we then zoom in a little bit to the Baltic Sea, this is data from HELCOM, the holistic assessment. We can see here that both with respect to eutrophication and contaminants, good environmental status is not in sight. And this means that every ship that is operating in the Baltic Sea will actually contribute to this not reaching the good environmental status. And therefore we can see that here is a great potential in reducing the pressures, and by reducing the emissions and discharges from ship, we can also contribute to a better environmental status of the Baltic Sea. But in order to do that, to quantify that reduction potential, we need to assess the extent of the pressures that shipping exert. And here is a brief example of how we are working with models to try to assess how much nutrients or how much contaminants that are coming out from the ships. So today, more or less all commercial ships are equipped with AIS transponder. That's actually a Swedish innovation, the automatic identification system, so that every ship is continuously sending out messages about their position and so on. So we combine this information on where the ships are operating and at what speed, etc., with information about the different ships. And here it's important to understand that every ship is unique. There are no two sister ships that are identical, yet there are, of course, more or less similar ships within different ship types. So if we compare a chemical tanker that is doing tank cleaning operations at sea with a large passenger ship that is carrying thousands of passengers, that is, of course, very different, giving rise to very different pressures. However, we combine the information about the activity and what the volumes produced. You remember the arrows from the picture of the ship in the beginning. And in the ship traffic emission assessment model developed by the Finnish Meteorological Institute, we can then combine this information and calculate the volumes that are being discharged or the emissions to air and what is being deposited on the sea surface, And then we can end up with an estimate of the load of, for example, contaminants to the sea. And when we're doing this calculation, this is what it may look like. Here is an example of copper. And as you can see, copper shipping and leisure boating is actually responsible for almost 40% of the copper load to the Baltic Sea if we compare with industrial point sources, atmospheric deposition, and river runoff. So shipping can be a significant contributor to different types of contaminants to the Baltic Sea. However, these assessments today, they still don't include tank cleaning, as you can see on the right here. So, the onboard sources that are included in our calculations here are antifouling paint, sewage, grey water, bilge water, and scrubber water, which is an exhaust gas cleaning methodology. So why is then tank cleaning not included? That depends partly on the lack of data. Today there is no single database to find information about what the ships are discharging, where they are discharging, and how much. And that will Anna talk more about. So thank you.
Yes. Thank you, Ida-Maja. So what you just learned is that ships have a lot of different liquid waste streams and waste streams in general. But what we will talk about today are the liquid bulk products that are regulated by MARPOL Annex 2, and are also included in the IBC code. So that is a code written by the IMO, the International Maritime Organization, to categorize and include different products that are transported in bulk. And the ships, the chemical product tankers, the ships, they can look something like this. And the reason for them doing tank cleaning is because they have different types of cargo in their tanks. And after unloading, they have to be ready for a new cargo. And in order to avoid contamination and ensure integrity of the new products, they have to clean their tanks. And this is often done at sea, and the discharges are often also done at sea. So I just want to say here that we are not including liquefied gases such as LNG or oils. As Ida-Maja said, they are covered by MARPOL Annex 1. So these ships can carry the same cargo, different cargoes in their separate holding tanks. And this sketch here shows 8 tanks, but a chemical tanker can have up to 60 tanks. So when the ships arrive to the port, as you can see here, it will unload its cargo. And following that, there's a lot of different requirements and procedures that have to be followed, depending on the classification of the cargo. So there are 3 categories, so 3 main categories. One additional that is called other substances, but I will focus on these 3, the X, Y, and Z compounds, or categories. So the X compound is the most hazardous one. And this can, for example, be biofuel blends with less than 70% diesel or gas oil. And then we have the Y compounds. Those are also deemed hazardous, but not as hazardous as the X compounds. And this can be palm oil, for example, or sulfuric acid. And then the Z compounds are the least hazardous, or classified as the least hazardous. And this can be liquid fertilizers, for example. So depending on the cargo, the ship must follow different procedures. And for category X compounds, it's stated that you can have 75 liters strip left. And the strip is what is left in the tank after it has unloaded its cargo. And they also have to do something called a pre-wash. And that means that when the ship is at the port, they have to rinse their tanks and until what's left in the tank is 0.1% mass, and then pump all of this water at shore. So they have to leave all the water in port before they can leave. Then we have the Y compounds. And again, you're allowed to have 75 liters left in the tank. And sometimes, so for example, with palm oil, you have to do a pre-wash. So this is for high viscous and solidifying compounds. But for some compounds, like sulfuric acids, you don't have to do that, and then you can have 75 liters left in each tank. Finally, for the said compounds, you have 75 liters of strip. There's no pre-wash requirements, so you can have 75 liters in each tank left when you leave port. And I just want to emphasize here that the cargo owner and the cargo buyer, of course, wants to have an efficient unloading as possible. You don't want to leave any cargo in the tanks. So there are some strategies where you can have, for example, super strip, that you can empty the tank down to a coffee cup, they say. Also with this, as you might have noticed, there is no complete ban on discharging. So you can always have little products left when you do the operational tank cleaning at sea and the discharge. So when and where is this happening? The regulation says that as long as the ship is en route at a minimum speed of 7 knots, at least 12 nautical miles from land, and at a depth of more than 25 meters, ships can do a tank cleaning operation and also discharge the water. So what that means is all of these purple areas are potential discharge areas. And just for brief thing is that the Swedish definition of en route means that a ship can unload its cargo in a port, go out into this purple area, do the tank cleaning and discharge, and then go back and load new cargo. In, for example, Germany, that is prohibited. You have to do that en route between 2 different ports. So moving on to these detected unknown substances or confirmed chemicals that have been found in the marine environment, here from the flight surveillance of the Swedish Coast Guard, these are 371 detections between year 2014 and 2021. And important to note here is that all of these dots are spills or discharges that can be seen from flight surveillance. So they have to be on the surface and change the surface structure. Those that sink or are distributed in the water, they will not be detected here. And this can come from legal or illegal operational tank cleanings. If we then combine this picture with other map layers, such as the Nature 2000 area, so Natura 2000, which is in green here, or the potential spawning area for Baltic cod that I know that you've been talking about here at Baltic Breakfast, here in blue, you see that there are areas of conflict where you have interest, both commercial and ecological, that can be impacted by these discharges. So what is being transported? Ida-Maja mentioned that we started to work with this in 2019-ish, and in 2020, we published this report with the Swedish Institute for the Marine Environment. And it's really tricky. It was really a tricky task because there are no databases showing exactly what is being transported, what is being discharged, when and where. But what we found out from this report, please read the entire thing at a later stage, but for now, it was about 5 million tons in Swedish waters in 2018. And we managed to identify 65% of these bulk products, and most of those are Y products, or category Y products. And then in the entire Baltic Sea area, it's at least 12 million tons, including those 5 million from Sweden. And here again, Y and Z compounds are the most common ones. So if we assume that the ships operate under the legal framework, we can say that what is being discharged is probably Y and Z products, and that is correlated with what is transported. So in 2018, that was sulfuric acid, sodium hydroxide, fatty acid methyl esters, FAME, in short, that is used in biofuels, and a number of other things. So that is how we can correlate that. But recently, as you might have noticed, there has been 2 years back, we have had different occasions where media has notice different things within the tank cleaning operation. So this is in Swedish. I'm sorry for those who do not read Swedish. But anyways, it's about the yellow goo that was washed up on shore on the Swedish west coast. It's also about new oil spills or chemical spills around Sweden. The detected ships that have been cleaning their tanks in areas where you are allowed to clean their tanks. And also a huge amount of spills that have been detected by satellites, but now they have to put down the investigation due to lacking mandate, basically. And as Ellen mentioned, just last week, we had a big discharge of palm oil discovered outside of Gotland. So what are the effects in the marine environment? So the short answer is it depends on what is discharged, essentially. There are many different products, as you have noticed. So these can obviously have a large variety in effects. But I will just go through some of them as an example. So here we have the long-tailed duck, and they if they are exposed to just a small amount of oil, and that doesn't have to be mineral oil, it can also be vegetable oils, they can suffer from freezing, immobility, and also death, essentially. Also, if the birds or fish or other organisms eat these oils or solidified products, they can suffer from starvation and also intoxication. And that is because some of these, especially fats, but all of these products can accumulate and absorb other toxins, such as metals or polycyclic aromatic hydrocarbons. So something that is, from the beginning, not toxic can become toxic because they absorb these contaminants. And then we also have, if they sink, for example, to the bottom, they can form slicks on the sediment surface, and that can suffocate the benthic environment, essentially. And you can also have an increased oxygen demand in the environment. If there are liquid fertilizers that are being washed out, they can enhance the eutrophication. That is a big problem in the Baltic Sea. And some compounds also have acute toxicity effects, so that means mortality, essentially, or more long-term effects, so chronic toxicity that leads to sublethal effects, like impairment of growth or development in different species. One thing to notice here as well is that these discharges are often a mixture of different products, the wash water, and also wash agents that you use in the tanks. And these can lead to synergistic adverse effects that we don't really know about. So one example here is that if you release acid or alkaline products together with other products, they can change the mobility and bioavailability in the water, in the discharge water, but also from compounds that are already in the environment, such as metals, for example. So based on this, what are we proposing? So in order to reduce the environmental impact, we need to reduce the loads. So therefore, we want Sweden to act for a mandatory pre-wash on all category Y products. So that also includes fatty acid methyl esters and tall oils that have been discharged. We know that they have been discharged. They are viscous and are solidifying, but they are not under this pre-wash demand as of today. So we really want to see that. We also want to prohibit the discharge of tank cleaning effluents in marine protected areas. As you saw, there is a big conflict there. We think it's important that we enforce strict reporting of liquid bulk products and tank cleaning operations, and this is for transparency and also traceability. So if we have a discharge, then we should be able to trace that back to a ship. And also, this is also important for the Swedish Coast Guard. If an accident happened and the Swedish Coast Guard doesn't know what's on the ship, that can also turn into something very dangerous. We also proposed that we change the Swedish interpretation of en route. So as you remember, if a ship leaves port, goes out to sea, do the tank cleaning and discharge, and then goes back, all of these arrows from the ship that Ida-Maja showed you, that would be additional loads to the environment, in addition to the actual tank cleaning discharge. So this and more you can read about in the policy brief that we have here on site today, and it's also online. And with this, I just wanted to thank you for listening and also end up with this quote. So this is from the Helsinki Convention, Article 5, where the contracting parties, that is us, undertake to prevent and eliminate pollution of the marine environment of the Baltic Sea area caused by harmful substances from all sources, including tank cleaning discharges. So thank you so much.
Thank you, both. Okay, let's see. Close. I guess I should do this. Voila. Okay, let's ask some questions.
Yes.
And I'll start, and you prepare. And Jenny will walk around with a microphone, so just get her or my attention, and you will get the questions. And for those online, there's a instruction on Silo on how to send questions. Okay, come guys. Thank you very much for a super interesting presentation. It sounds like there's a lot of things coming out from ships. And I was just thinking of your copper example, 40% coming from shipping or from also leisure boating. Is that like an outstanding example, or are there more substances that...
Yes, copper is an outstanding example in terms of, 40%, and we, in the list of not included waste streams, there is also cooling water. So every ship is having anti-fouling paint on the hull on the outside, which is this 40% ending up in the Baltic Sea. But we also know that you have an active anti-fouling system in the cooling water that may be actually equal the size. So copper is that is really an extreme example. But at the same time, we know, especially from these the exhaust gas cleaning system, which is a little bit of a paradoxical name, as it transfer pollution then to the marine environment instead. That wash water will contribute to, in the order of the substances that we have looked into, it can be up to 8 and 9%, both from vanadium, for example, another metal, but also other individual organic substances. So it's, yes, copper is extreme, and it's a very prominent example. But and we also have colleagues working on anti-fouling paints without copper. So it's as you can see, it's a potential there in actually getting a big reduction from changing the routines on ships.
Interesting. And do I understand correctly then that you differ from fossil oils and vegetable oils? And of course the origin differs, but are they so different when they reach the environment? Are they like a lot more toxic, or do they not break down, or what's the difference? Why do they have different categories?
I think there are many reasons for that. Historically, you regulate mineral oils as a fuel in a different annex than chemicals that are more like cargo, not used as fuel. But I think maybe that now with the biofuels coming in, that border is it's a bit more blurry, perhaps. As you saw, some of the category X compounds actually contain mineral products or fossil products, but to a lesser degree, so to say. But I would say mineral oils are inherently more toxic than vegetable oils, yes. But the vegetable oils also have the potential of doing a lot of damage when they are released into the environment. And as I showed you with the long-tailed duck, for example, getting that in the feather, essentially leading to deaths of these birds, and also the accumulation of toxicants that we don't really know what are the true impact of that. So I think regulating them differently is it's not really controversial, but having stricter rules on what we discharge into the marine environment is very important.
Okay. you preparing with your questions? I have one. I know we talked about this before, Ida-Maja, but you're proposing quite a lot of restrictions or on Swedish rules. Whereas I know that since it's a very international business, that many asks for IMO to regulate all. How come you still go forward with like Swedish HELCOM policy actions?
I think you need to work on both at both perspectives or from both perspectives. So it's true that that's kind of a natural law of the shipping industry. It's operating globally, and it's very important for the industry to have global rules to ensure that it's a level playing field and so on. But at the same time, there are also, for example, the Baltic Sea is pointed out as a special area with respect to for example, Annex 1, then the mineral oil and so on. So there are some flexibility, and within that flexibility, the individual states, it also comes closer to the coastal waters. You have more possibilities to regulate yourself. So I think it's important to both investigate to move on faster with the things that we can regulate ourselves in Sweden or at HELCOM level. But at the same time, of course, we need to strive for a long-term change also globally. But that historically, it takes a lot of time. If you say the Ballast Water Convention, it was finished in 2004, I think, and then it was entered into force in 2017. So it says something about the time horizon that we are working on, and as we know, the status of the Baltic Sea in particular, but actually the sea in general, the ocean, it's not good, and we need to find faster action.
Okay, and one last one. On the en route concept, you say that they go out at sea and they clean and then they go back. So your policy recommendation would be that they would only clean when they're between ports, right? Would that create like more transport because maybe they want to load cargo again in the same port, or how could you stop that from happening?
No, so our recommendation is we would prefer that nothing is discharged. We don't oppose the tank cleaning itself, but the discharging in a sense. The concept of having these en route interpretation that we have in Sweden makes it really hard to control what ships are doing. Are they just doing this detour out, or are they actually going somewhere? And the industry is built up like that you often you have these you unload in one port and load in another. If you want to do it in the same, you could do the tank cleaning in the port actually. There requires infrastructure, of course, but it could be done, and then you would at least not get these extra pressures just going out and taking these unnecessary detour, basically. So it's not a matter of forcing ships to go to different ports that we want to manage with this proposal. It's more of a not going out just to do a tank cleaning and discharging it. And also get a harmonized interpretation of the regulations. We have Germany and Finland who has done this other interpretation.
So instead, getting the cleaning all together in the port.
Sorry. Yeah.
Yeah. Is it possible today? Could all ships clean everything in the port?
That would require infrastructure changes, but if there are other options, I don't think the infrastructure will happen. The changes in the infrastructure will happen either. So the chemical tanker business wants to follow the regulations. So and we have to make it level playing field, as Ida-Maja mentioned also with IMO, that if we have this ban of discharge in the Baltic Sea area, then everyone has the same opportunities, basically.
All right. So I'm going to open up for questions from you guys. Here we have 2 experts, so take the opportunity. And please say your name and where you're from.
Okay. Hi, my name is Amanda, and I'm from Preem, so I work within shipping. I was just thinking about the infrastructure problem that you talked about, because it's great to do a lot of pre-wash and to not pollute the ocean, of course. But right now I feel like there's a lot of problems on how to discharge the pre-wash water. So it's not, in some ports there are no options to do that. And also in some ports there are options, but they can't take all of the water. Do you have any solutions for this, or have you started looking into how to solve the infrastructure problem?
Do you want to go? Or?
I can start. I can just say that we fully acknowledge that insight, and in October last year we had this one-day conference as well, inviting also the ports and the cargo owners and so on. So no, unfortunately, we don't have a quick and neat solution to propose. We realize that this is a huge effort, but we need, at the same time, we also realize that just because it's a big question, we cannot avoid it. We need to handle it, and of course, one cannot put rules in effect from one day to another without resolving that. But I envision that will need further investigation how to do that in a good way. But again, as Anna mentioned, that we don't even have access to all the information about what is being transported, where it's being discharged, and so on. It's a complex question. And if I may add one thing more that we have not touched upon in the presentation, but Anna, you mentioned a little bit about the compliance monitoring. If we are going to have regulation, because as it is right now, and as Ellen stated as well, many of these discharges at sea, they are legal, and that makes it really difficult for the Swedish Coast Guard when they are doing the compliance monitoring. Then they don't only have to find out which ship was discharging. As it is right now, they also need to find out, is it a legal or an illegal discharge that we are talking about. And at a societal cost or resource perspective, we also need to take that in consideration, the cost of the compliance monitoring efforts. So it's not only the infrastructure that is a big problem to solve, but also other parts that are challenging. Absolutely.
Tank, Linus Edberg. I can just, like Amanda from Prim said, with the pre-wash water, one of our vessels create about 35 to 40 cubics of pre-wash water. And on the Baltic side of Sweden, we have to take it by truck. And 1 to 2 trucks, and it's tricky and means a lot of planning to make it efficient.
Absolutely, and of course one need to, in that assessment, also bring in the environmental impact from those truck transports. I completely agree.
Are there ways to not use as much water when you wash in the harbor? Are there like new techniques, or could there be new techniques, and what's stopping that?
I mean, I think the super strip technique that I mentioned, because then you reduce what you have left in the tanks, so it requires less water to dilute it enough, so to say, and rinse off all of it. But that doesn't apply to all cargoes. So these more solidifying compounds, then super strip doesn't seem to work as good, at least. But I think also, so this is a bit, it's not science Anna talking now, it's me as a person, but I think it's, you can change maybe the strategies or the logistics of how you plan your cargo so that you don't have to wash your tanks in between, maybe carry the same cargo. I think maybe it requires some restructuring within the industry so that you, if you can have the same cargo transported, then you don't have to do these tank cleaning operations. And that might save you time and also water, and most importantly, you won't discharge anything to the marine environment. So I think there are many, it's not one solution to this problem, there are many solutions to this problem. And I think with new regulations and also this collective work that the Swedish Institute for the Marine Environment has started and is ongoing, I think it's absolutely possible to do it. So, yes.
Hi, my name is Payam. I do research on international shipping, political economy independently. My question was about also the data on discharges, this historical data, and that we don't know whether there's illegal and legal discharges. We just know there are discharges. And also with this caveat that we don't really know from the sort of physical data whether this shows the full picture, that there could be more, pollution happening. And since, we talked about the industry, there's a lot of regulation, as you said, there's levels of regulation. Do we know how it will pan out, or do we know the sort of the enforcement of the rules? If the future changes can lead to, more cooperation or less, or you know what I mean? Like there could be more illegal discharges, if we try to enforce something that they are not willing to really carry out. And by them, I don't mean just the company. It could be the crew, or even, levels of the crew. So yeah, I was just thinking about that.
Yeah, you're right. I don't have an answer, but of course, if you say that if I interpret your question correctly, that if you say now we do not allow any discharge anymore, then everything will be illegal, and how will we follow up to ensure that anyone that is not following the rules, that they get some kind of consequence from that. I just think, Anna, you know this better than me from the seminar last year with the Swedish Coast Guard, but there are still no single tank cleaning operation in Swedish water, right, that has led to...
I think some ships have received fees, like in very minor. But it's hard with tank cleaning also, there are no methods of calculating how much is being discharged. So it's very hard for them, for the Swedish Coast Guard to assess whether or not discharge is illegal or legal. Mm. It takes time, and then after the ship has left Swedish waters, and then you don't have any saying anymore. So, but of course that is a risk, and that is why with like enforcing regulations, and if no one will follow them, everyone will become illegal, basically. So that's why we want to. I mean, this has to come from many different angles in doing this. And I believe me and Ida-Maja's job here is to say that we cannot continue to discharge contaminants into the Baltic Sea or the ocean in general. And then we have to work together to come up with solutions for that.
And we have Coast Guard here.
Hello, Jonathan, Swedish Coast Guard. So I was the one investigating the palm oil spill or discharge last week. And our problem is that even with the current regulations, we have a lot of evidence struggles to get the prosecutors to actually follow up and get the different kinds of companies to pay the fines, since they leave the waters so quickly after discharging. So we propose a number of things, but especially, I mean, we talk about pre-wash problems to get tank clean waters from A to B and so on. from our perspective, if we just could get the current, how do you say it, the current rules to actually be enforced by the prosecutors, we can actually go a long way, even now. So from my perspective, it's about raising awareness with the prosecutor's office. So this is a very good start. And a question, do you have any thoughts about raising the standards for pre-wash inspectors to higher the demands on what they actually see during pre-wash certification? Thank you.
That will have to be a quick answer, girls.
Yes. So I think there's ongoing work now with trying to improve these inspections, manuals, basically, or like how to proceed during these inspections. And I do not know the details of that, but I think your voices have been heard in that question, basically. Yes.
Yes, I can confirm that the transport agency are working to increase the competences there. So, yeah.
Thank you so much, and thank you, everyone. Actually, I always have this last question. I'm going to draw 1 more minute here. So if you were the king, or if at least you were like some kind of position to decide what we're going to happen right now to improve the situation, so keep like big dream. What would be your first priority action to address?
One sentence: stop discharges to the ocean
All together.
Yes.
Great.
I copy that.
Well done.
Yeah.
Okay, that's not in your policy brief, though. But it's great to know that's what.
But we are not kings in the policy
No,
brief.
we're not kings there.
Voilà.
I have to.
Okay, thank you, everyone, for joining us today. I think this discussion will continue. We have lots to work to do. And go out and do your job and save the ocean as usual. Bye.
Thank you.
Thank you.